Howdy folks, so we're moving on to chapter 15 and we're going to study a brand new classification of functions here, multivariate functions, and we're going to learn how to do calculus with these functions. So this is a departure from what we were doing before, and so just to emphasize that, let's go ahead and look at the types of functions that we're going to study in this. So we're going to study functions that look like this. They're going to look like functions which map from Rn to R. So we're going to have, this would be a function of n variables. Let's just say that this is a function of n variables, and we're mapping it into the real numbers. So what we're going to do is we're going to call this function a real valued. That has to do with the output, right? The output here is a real value as opposed to an ordered pair or a vector, and it's multivariate because we inputted multiple variables into this. There's other ways we could represent this, so I just want to show you. Another way to think about writing that domain space is to cross n copies of Rn with itself, or of R with itself, and you do this a total, put another x there I guess, of n times, and this function maps then to the real numbers. Okay. So another way to interpret this is this function takes n tuples from Rn and assigns one single n tuple a single value in the real numbers. Now we've studied these functions before, but we haven't done it with the domain having several variables. It just had one variable. So when n equals 1, the function maps from R to R. This is just the real valued functions that you studied in algebra and calculus 1. And let's just mention where its graph lives. So this maps from the real numbers to the real numbers. Its graph lives in R2. And so when we thought of sketching those real valued functions from Calc 1, we called this the domain axis, and we called this the range axis. And so when we said, for example, if we plugged f of 2, plug a 2 into this function and it's outputted a 3, then we went ahead and we made that connection between this domain value 2 and this range value 3, and we represented it graphically as so. So if n is 2, then our function is going to map from R2 to R, where f takes two inputs. It's going to take an input that we call x and an input that we call y, and it's going to output the real number z. So we would think of this, if we wanted to represent it with that cross notation, it would be r cross r, and that gets mapped to r, and we'll use values from this real number line, we'll represent them with x, values from this number line with y, values from this number line with z. And of course, that labeling of x, y, and z is completely arbitrary, and we can change that up however we wish. But it's most common to use x for the first real number line, y for the second, and then think of the output as z. And so in this case, our ordered triples are going to look like this. They're going to look like x, comma y, comma f of x, y. Now this is really important, folks, here. So when we had this ordered pair, 2, comma 3, you never had to do too much thinking to realize, hey, this is the domain value, and this is the range value. Now in this case, when our ordered triplets look like x, y, and comma f of x, y, it's a little bit harder to see. If we were looking at, say, this ordered triplet right here, 2, 3, 1, it's hard to kind of make the mental shift from this work that you've done in one variable functions to the work here where we recognize this is the domain value and this is the range value for this multivariate function with real outputs. Now we've already looked at the graphs of some multivariate functions. We just haven't used the multivariate function notation, but the graphs of these ordered triples we're going to call surfaces in R3. And I would like to just emphasize that we have two inputs and a single output. When we go to think about graphing that, so we're going to think of taking the xy plane here, which maybe we'll put x on this axis and y on this axis. That's the domain. And then just like we did in the real valued case, we'll cross that with a third dimension, and there we have our z. But I want you to think of that plane as being the xy plane as being the domain space, and then we put it with the range space here, just like we did over here. But it's a little, you've got many years of experience working with this Cartesian coordinate system. This one is a little bit less familiar to us. So just to show how we can extend this, we could look at this function right here. By the way, this function is mapping from R4 to R, and we could represent it this way. And this graph then would live in what space? This, if we were to think about these ordered n-tuples, this would have the ordered n-tuple would be x1, comma x2, comma x3, comma x4, comma w. And we say, okay, well, these would be the domain values, and this would be the range value that outputs from it. And this graph then, if we wanted to try to plot these, in this case 5 tuples, it would have to live in R5, which is something we can't really visualize, but we would still say that the graph lives in R5. Finally, I just want to make sure that we completely understand the distinction between what we were studying in the last chapter, chapter 14, and what we're studying now. In the last chapter, we studied functions that look like f, which map from the real numbers to Rn. So please contrast that with what we're looking at here. So the domain space in the functions we're going to study now has n dimensions, and it outputs a single real value. And what we had been studying was where the domain space was a real parameter, like t. We usually use t as a parameter. And the output was either considered a point or a vector in Rn, and in chapter 14 we considered that as a vector as opposed to a point, but that's the distinction. So our domain value was t, and that outputted something like x1, x2, x3. It outputted a vector. Very different from what we're looking at here. So we're going to get comfortable with these multivariate functions in the next couple of videos, so join me for those.